Welcome to Parallel Frontiers. Today we examine why, despite our achievements in space, the red planet is still a distant aspiration. We have walked on the moon and lived aboard the ISS, yet Mars remains stubbornly beyond our reach. The idea of colonization endures, but reality is constrained by physics, biology, and the vastness of space. To grasp the difficulty, we must begin with the enormous emptiness separating Earth from the Martian surface. Mars is a barren world that demands flawless technology and human resilience far beyond anything we have attempted before. The International Space Station orbits just 400 kilometers above Earth, a trivial distance compared to a voyage to Mars. At its furthest point, Mars is 1,000 times farther than the Moon, and 1,000,000 times farther than the space station. Such distance creates an immense logistical challenge that scientists and engineers have wrestled with for more than 50 years. Earth and Mars are constantly moving, so the gap between them is never fixed, changing dramatically over time. We cannot launch at will. Missions must wait for a precise alignment known as the launch window. This vital opportunity appears only once every 26 months, imposing rigid timelines on every mission. Missing it means waiting over 2 years for another chance, slowing progress and driving up costs. Even with ideal timing, the laws of physics require a long, slow cruise through space. Using current propulsion, a one-way journey lasts roughly 6 to 9 months, exposing astronauts to deep space the entire time. Including the stay on Mars, a full round trip keeps astronauts away from Earth for nearly 3 years. Survival demands far more than personal gear. Hundreds of tons of supplies are required to sustain a crew. Unlike travel on Earth, every molecule of air, water, and food for years must be carried along. This results in an enormous logistical load, with heavy life support systems adding major mass to the spacecraft. To lift such weight, we need the most powerful rockets ever built. NASA created the Space Launch System, or SLS. Although SLS is intended mainly for the Artemis lunar missions, it is insufficient for establishing a Mars colony. Then there is SpaceX and Starship, a stainless steel giant built with the goal of making humanity multiplanetary and reaching Mars.
It's fully reusable.
While SLS is expendable, Starship is designed to be fully reusable, potentially slashing transportation costs. Future versions like V2 and V3 are planned to carry up to 200 tons, transforming how infrastructure is moved. Yet constructing a massive rocket is only the beginning. The true obstacle is refueling it in orbit. A fully loaded Starship uses nearly all its fuel just to escape Earth's gravity, reaching orbit with empty tanks. To continue to Mars, it must be refueled by tanker spacecraft, a maneuver never attempted on this scale. Moving supercooled liquid fuel in zero gravity is a complex engineering challenge SpaceX is racing to solve. It could require 10 or more rapid launches to refill a single ship, demanding an unprecedented launch rate. Only after refueling can the journey truly start. But the voyage itself presents even greater dangers. Beyond Earth's magnetic shield, astronauts face galactic cosmic rays that penetrate metal and damage human DNA. This radiation brings serious long-term risks, including cancer and acute sickness, threatening crews before arrival. Microgravity is another hidden threat. Without gravity, bones weaken and muscles waste away rapidly during transit. The cardiovascular system is affected as well, with the heart reshaping and vision potentially suffering permanent damage. Astronauts must exercise for hours daily merely to slow this decline, though it cannot be fully prevented. Once they reach Mars, they must work immediately in brutal conditions, despite bodies weakened by months without gravity. The Martian environment is hostile. Its soil contains perchlorates, and its thin atmosphere offers no shield from solar flares. Perhaps the toughest challenge is psychological. Earth becomes a tiny dot, a constant reminder that there is no easy return. On the ISS, home is close. On Mars, isolation is complete, creating mental strain we can barely comprehend. If a failure occurs midway to Mars, there is no abort option. Turning back is not possible. Unlike missions to the Moon or ISS, no rescue team can come. Assistance is always at least 6 months away. History has left painful reminders with Challenger and Columbia. Space shows no mercy, and errors are often deadly. For the first settlers, the danger is extreme. They are pioneers who may never see their home world again. Elon Musk has acknowledged that deaths are likely in the early stages. It is the harsh cost of exploration. Still, we move forward. Technology advances daily, and while the obstacles are immense, they are not insurmountable. Robots and autonomous systems may lead the way, constructing safe habitats before humans arrive. Innovative materials and underground shelters could address radiation, transforming Mars into a place humans can live. Progress in biology may enable efficient food production and air recycling, forming closed-loop systems for survival. The idea of a thriving Martian city is no longer pure fiction. It is a plan already taking shape. The people who will walk on Mars are probably already alive, gazing at the night sky with curiosity today. A successful return journey will prove our achievement, completing the cycle and confirming us as a multiplanetary species. From the moon to Mars and beyond, expanding human awareness into the cosmos is our greatest shared journey. It will be difficult, dangerous, and costly, but the goal justifies the effort. We do not pursue Mars because it is easy, but because it pushes us to surpass our limits. Every challenge discussed, distance, fuel, radiation, isolation, is being addressed by the world's brightest minds. Solutions are emerging. It is no longer a question of if we will go, only when. As technology evolves, the doorway to Mars opens wider. The red planet awaits our leap. Mars is only the beginning. Once these challenges are mastered, the rest of the solar system lies within reach. Yet we must remember that as we reach outward, Earth remains our only perfect home. We journey to Mars not to abandon Earth, but to ensure the survival of consciousness whatever the future holds. The Martian horizon calls to us. It is unforgiving, yet it offers a future shaped by imagination. Soon, a human voice will transmit back to Earth, confirming that we have arrived to stay. That first footprint in red dust will signal a new chapter in human history.
Accelerated performance,
Distance,
structural
timing,
integrity,
logistics,
efficient timing, and
and
advanced
biology.
threat protection.
These are the 4 barriers we must overcome to reach Mars. With governments and private companies collaborating, those barriers are weakening, and the path is opening. Would you choose to join such a mission? Would you leave everything behind to help build a new world? Share your thoughts in the comments. The conversation about our future in space belongs to all of us. Thank you for watching Parallel Frontiers. Subscribe as we continue exploring the mysteries of the cosmos together. Goodbye.